If I want to find the equation of the line, if y equals 2x plus 1, this is a kind of relation between x and y. Y is equal to 2x plus 1. I want to graph this relation. So take values for x, like when x equals 0. What is the value of y? It will be 2 times 1, 2 times 0. 0 plus 1 is 1, so y is 1. So the first ordered pair is 0 and 1. The first ordered pair is 0 and 1. When x equals 1, for instance, what is the value of y? You will put instead of x 1, so 2 times 1 is 2 plus 1, 3. So y equals 3. So it's 1 and 3. When x equals 2, what is the value of y? Y equals 2 times 2 is 4 plus 1 is 5. So y is 5. So it's 2 and 5. On xy coordinate plane, I have values for x1, 2, 3, 4, and on the left minus 1, minus 2, minus 3, minus 4. And when we go up, we have 1, 2, 3, 4, 5, and down minus 1, minus 2, okay, negative 3. The first order, the pair is 0 and 1. So 0 and 1 in this place. It's 0 and 1. This point 0 on x and 1 on y. 0 and 1. The second ordered pair is 1 and 3. So the ordered pair is 1 and 3 in this place. 1 on x, okay, and 3 on y. And the last one, 2 and 5, 2 on x, and when we go up, we'll get 5, 2 and 5. We observe that all points are on the same straight line. All points are lying on the same straight line. Join up them. So I joined up them and draw 2 arrows. Okay, this is the equation of the straight line. I want to analyze it again. This line cuts y-axis at the point 0 and 1. Look at the line, you will find that the line, which is 2x plus 1, cuts y-axis or intersects y-axis at the point 0 and 1, this point. And if we want to find the gradient of the line, what is the gradient? The gradient is rise over run. The gradient or the slope of the line is rise over run. It's rise over run. So take 2 obvious points, like this point here and this point. I want to move from this point to this point. So we will run 1 and we will rise 2. So the gradient is rise, and pay attention. When we rise means up and down. Rise means up and down. This is the rise. When we go up, it's a positive. When we go down, it's negative. And run. Run is right and left. Right and left. This direction and this direction. When we go to the right, it's positive. When we go to the left, it's negative. Once again, rise means up and down. Up, positive, down, negative. Run, positive on the right, negative on the left. So we will run 1 and we will rise 2 units. So the gradient is 2 over 1. It's a 2. So if we looked at this line, we will find that the gradient is 2 and the y-intercept is 1. Let's go back and look at this number, which is written in front of x. Y equals 2x. So 2 represents the gradient and 1 represents the y-intercept. 1 represented the y-intercept. I want to summarize it again. So I have the relation y equals to x plus 1. How can we graph this relation? Just take points for x and check the points of y, like 0 and 1. Then plot the point 0 and 1. 1 and 3 when x is 1. What is the value of y? It's 3, 1 and 3 in this place. 2 and 5, 2 and 5 in this place. Join up them. I finished it. So when it comes to analyzing the gradient and the y-intercept, the gradient is the number written in front of x. This is the gradient. What is the gradient? From the drawing, it's rise over run. What is the y-intercept? It's 1. When comparing them, when comparing the drawing and the equation of the line, y equals 2x, it's 2x plus 1. We noticed that this 2 represents the gradient. And this one represents the y-intercept. That's it. So if I have the equation y equals 2x plus 1, without drawing, without taking points, the gradient is 2. This is the gradient. The gradient is 2. And the y-intercept is 1. This is the y-intercept without graphing. And if I have an equation like 2y equals 10x plus 12, I want to find the gradient. So to find the gradient and the y-intercept without graphing, the equation must be written in this form: y equals mx plus c. What is m? M is the is the gradient. It's m. What is c? C is the y-intercept. So in this case, we have 2y. I want to write it as y. So divide all terms of the equation by 2. Y by 2 exactly, just to get y. To get rid of this 2, I want to get rid of it just to get y. So 10 divided by 2 is 5x, and 12 divided by 2 is 6. So the equation now is written as y equals 5x plus 6. So in this case, because the equation is written as 5x plus 6, this is the form I need. Is y equals mx plus c when comparing them. So the gradient is 5. This is the gradient is 5, and the y-intercept is 6. This is the gradient. And the gradient, we write it as m. So m equals 6. And this is the y-intercept. Y-intercept. The y-intercept is 6. Okay? We call it c. So c equals 6. If I have an equation like 3y minus, let's say, 15x equals 12. I want to get the gradient and the y-intercept. The equation of the line is written in the form y equals mx plus c. The equation of the line is written in the form y equals mx plus c. And if we compared this equation, 3y minus 15x equals 12, by this one, they are not the same. I want to write it as y in a side. So how can we get rid of minus 15x? I want to get rid of minus 15x. To get rid of minus 15x, add 15x to both sides, plus 15x and plus 15x. Minus 15x and plus 15x are going to be cancelled. You left with 3y. equals. You know 12 plus 15x, they are not like terms. So write 15x plus 12. I'm still having a problem. What is the problem? I have 3y. So to get rid of 3y, divided by 3, divided by 3, divided by 3. So y equals 15 divided by 3 is 5x. And 12 divided by 3 is 4. So now we can find the gradient directly. The gradient is 5. And what is the y-intercept is 4. That's it. So the gradient is 5 and the y-intercept is 4. Once again, if I have an equation like y equals 2 over 3x plus 1, and I want to graph this relation, so take values for x, easy values for x, and check the values of y. If I took x0, so we will substitute x0, you will end up with y equals 1. So 0 and 1, the first order pairs 0 and 1. Okay, and when when x equals 3, you will find that y equal 2 over 3 times 3 plus 1. So y equals 3. It's 3 and 3. When x equals negative 3, the value of y negative 3 and negative 1, it will be negative 1. Plot the points as you see. You will get a straight line. And I want to show you a way, another way in drawing the equation of the line. Pay attention. How can we graph the relation, this relation, without taking points? Look at the y-intercept. The y-intercept is 1. So it's 1. Here is 1. And put a point on the y-intercept. This is the y-intercept. And 2 over 3. You know 2 is the rise. 2 is the rise. And 3 is the run. Again, 2 is the rise. And 3 is the run. So from this point, 1, you will rise 2 and run 3. You will rise 2, I'm rising 2, and run 3, and put a point. And then rise 2 and run 3. You will put a point here. And rise 2 and run 3. Now we have points, this point and this point. Join up them. Then you can get the straight line again without taking points. Okay? Look at this equation. Y equals 5x plus 1. Minus 1, sorry, and I want to graph this relation without taking points, without write x equals 1 and then check the value of y and y x equals 2. No. I want to graph it without taking points. So this equation, y equals 5x minus 1. Firstly, what is the y-intercept? The y-intercept is minus 1. So go to minus 1 down and put a point. This is the y-intercept. And the gradient is 5. So write this 5 as 5 over 1. 5 is the rise, and 1 is the run. So rise 5, count, you will count 1, 2, 3, okay, 4, 5. This is the rise. 1, 2, 3, 4, 5. Then run 1. Then put a point. Then join up them. This is the equation of the line. This is the line. I represented it graphically. That's it. Pay attention. Yeah, the first step, you will find rise over run. And instead of finding rise over 1, we can find the gradient by subtracting y2 minus y1 over x2 minus x1. Do you know that the change in y, this is the rise, and the change in x, this is the run. So this is the run, and this is the rise. I want to show you that the gradient, we can find the gradient from subtracting y2 minus y1 over x2 minus x1. So m in this case is going to be what? 8 minus 6 over 6 minus 2. Again, 8 minus 6, it's y minus y. It's y, this one, minus y. 8 minus 6. Minus x over x minus x, 6 minus 2. So 8 minus 6 equals 2, and 6 minus 2 equals 4. So what is the gradient? The gradient is half. How can we find the gradient if we have 2 points? To find the gradient, it's y2 minus y1 over x2 minus x1. This is the gradient. So the gradient is half. So the equation will be y equals half x plus c. I don't know C. What is C? C is the Y-intercept, because this line is passing through the 2 points, 6 and 8, 2 and 6. So we can say that 6 and 8 satisfies the relation. 6 is x and 8 is y. 6 represents x and 8 represents y. So instead of x, you write 6, and instead of y, you write 8. Again, instead of x, you write 6, and instead of y, you write 8 in the equation. So 8 equals half x. It's half times 6 plus c. So 8 equals half times 6 equals what? 3. So 3 plus c. How can we get c minus 3 from both sides? So c equals 5. Now we have the gradient and we have the y-intercept. So write the equation as y equals half x plus 5. That's it. And if you want to check it, you will find that this line cuts y-axis at this point which is 5. So y equals half x plus 5. This is the equation of the line. How can we get m again? It's the change in y over the change in x. y2 minus y1 over x2 minus x1. That's m. And how can we get c? Just take a point. The line passes through it like this point and internalize it in the equation. 6 is x and 8 is y. So 8 equals half x. Instead of x, write 6, and instead of y, write 8. So 8 equals half of 6 is 3. 3 plus c, so c equals 5.